Hello, everyone, and welcome to our next subtopic of angles and angle measures, which is the length of a circular arc. Before we proceed, I would like to ask you a question. Since we know that trigonometry is about triangles, why do we need to discuss a topic that is not even related to triangles, which is this one, the length of a circular arc? So there are two reasons. The first reason is that uh, this one is related on how you find the angle in radians. I'm going to explain that later. Then the second reason is that its application is important to our to our next topic, which is the unit circle. Now I'm going to explain more about that on that video about unit circle. All right. For now, let's focus on discussing this one, the length of a circular arc. All right. So let's now proceed. Let's have a recall. I told you the first reason why we need to discuss the length of a circular arc, which is basically it is related on how you find the angle in radians. So we know that radians is another way to measure angles. And to find the radians, you just basically divide the arc length by the radius of a circle. All right. So for example, you have a given central angle, then of course, you have these two line segments, which are your radii, or in singular, your radius. Then this arc, which is intercepted by the central angle, is your arc length, or represented as S. Just basically, divide S by R to get the angle in radians. All right. Now, how about this one? Let's just say that the angle is given and the radius is given, and you are asked to find the arc length. So how will you find the arc length? All right. So of course, it involves some formula. No, actually, it's only one formula. All right. So the formula is just from this basically. All right. The formula on how you find the arc length is just this one. All right. All you need is just application of algebraic transformation, or in other words, derivation. All right. So let me show you how is it done. Let me show you how it is done. So this is basically the formula on how would you find the angle in radians. All right. So here, what we're going to do is derivation. Since we're looking for the S, or your arc length, we're going to make S alone in that side of the equation. Because remember, if you recall in your algebra class, if you're going to find a specific variable in an equation, all you need to do is to make it alone. For example, x plus 3 is equal to y. You want to find your x. So how do you find your x in this equation? Make it alone. So just transpose 3 on the right. You will have x is equal to y minus 3. Once you transpose this term, it will become negative. And that's it. That's how you find your x. All right. And you can actually interchange the position of the left and the right. So for example, you want to have x on the right and this side will be on the left. No problem. We have y minus 3 is equal to x. All right. Another example is, let's just say you have z all over y is equal to, let's just say, x. So you want to find your z. All you need to do is to make it alone. So I'm going to multiply both sides of the equation by y. So what will happen if I multiply y in this side, this would be cancelled. So I will have z and I will have x, y. All right. So that's it. I found my z. So the way how I derive the equations is similar on how are we going to do it here. We have this one, right? So we need to find our s. So just multiply both sides by r. All right, so there we go. So r times theta, we will have r theta. And s all over r times r, we will just cancel it out. We will have s. So that's the result. All right. And as I said earlier, we can interchange the positions of the left and on the right. So we can have s is equal to r times theta. I actually forgot what identity is this. Like, you can basically put s here and r theta here. You can just interchange the sides basically. I forgot that identity. I think it's transitive property. Nah, maybe I might be wrong. But I think you get the idea. All right. So there you go. This is our formula. The formula on getting the arc length of, wait, yeah, basically that's it. Getting the formula, getting the arc length. There you go. Forgive me. But yeah. So this is the formula you're going to use to find the arc length. All right. But you see, it's actually easy because all you need to do is radius. All you need to know is that you need to have a given radius and a given angle, right? So that's it. However, there's one thing that you need to know, all right? Before you proceed substituting any given value in this formula, you need to know one thing, that theta should be in radians, not in degrees. All right? It should be in radians, not in degrees. Why though? Why is it that the theta should be in radians? So let's just say we have this one, right? S all over R, right? Let's just say our arc length is 3 meters and our radius is 1 meter. Let's substitute that. So here, once we divide 3 by 1, what will happen here is that we will have 3 radians, right? Because we're looking for the angle. So what I'm trying to point out here is that the way how you found the angle here, which is in radians, therefore you should remain it as radian. All right? Let me say it one more time. The way how you find the angle here is always in radian. Therefore, the angle here should be in radians. All right? So what if it is in degrees? Then convert it into radian. All right? Plus, it actually makes sense. You know why? Let's just say, I'll give you an example. Wait, let me just draw a circle here. All right? Suppose this is 60 degrees. And the radius, let's just say 2, right? 2 meters. All right? And your job is to find the arc length intercepted by the central angle. So you need the formula. All right? So let's just say we just let theta be degrees. Here's what will happen. The radius, of course, 2 meters, times theta, we have 60 degrees. So the result would be 120 degrees meters. Tell me in reality that you had encountered this type of measurement. Tell me. Because in reality, there's no such thing as 120 degrees meters. For example, you want to you want to find the length of this one, there's no such thing as 120 degrees. All right? So what I'm trying to point out, if you're looking for the length, let's just say length of the curve, length of a shape or side of a triangle or anything, just the length itself, all right? Just the length itself, there's no such thing as degrees, all right? There's no such thing as that. So what we're going to do is we're going to convert this angle into radians, all right? Now here's the thing. Okay, we know the first reason why the theta should be in radian. Now, this one, there's a second reason why we need to convert it into radian. All right? If you're going to find the arc length, okay, we're talking about the length of the curve, all right? The length, all right? Not the angular distance, the length, okay? Length is different from the angular distance. All right, remember that. So let's just say that we have this one and we're going to convert it into radian. So why do we need to convert it into radian? All right, if we're looking for the arc length with the use of this formula. All right, look at this one. Okay, look at this example. I divide 3 meters by 1 meter. What happened? I mean, of course, the answer is 3, right? So what will happen here is that the units are cancelled. 3 meters all over 1 meter, they are cancelled. So we have 3 all over 1. So the answer here is 3. So in other words, it is unitless. There is no units. If that's the case, then why do we have radians? Let me give you a recall. All right. Recall that here, when you're going to find an angle by dividing the S by R, you need to put radian. All right. Even if it's unitless. Oh, wait, sorry. You need to put radian. All right. No matter your given numbers are, whatever your given radius or your given arc length, okay, you need to still put radians. Okay. Why though? Because this is to avoid confusion. This is to distinguish a number, a real number, all right, and a number that is actually in angles, all right? Because usually we know angles that are in degrees, all right? We know that. But sometimes there are angles that are not degrees, just like this one, 3 radians or pi all over 2 radians. So to avoid confusion, if the number is not in degrees, but it is an angle, we're going to put radian. Radian may not be a unit, but it will represent that this number is not an ordinary number. It is actually an angle. All right? It is actually an angle, but no degrees. So we're going to put radians to avoid confusion. Which is why when we're going to have a practice about converting a radian to degrees to radian, I told you that don't forget to put radian so that you won't be confused if that number is just a real number, constant number, or it is just actually a what? An angle. All right. I hope you understood what I mean. Okay. So that is why, since it's unitless, but it's an angle, so we're just going to put radian. All right. So going back here, right, we have 60 degrees. Now convert it into uh, radians. Convert it. So remember, if you're going to convert degrees to radian, you will multiply this one by what? By pi all over 180 degrees radian, right? So multiply 60 degrees by this one. What would be the result? 60 degrees and 180 degrees are both divisible by 60 degrees. So we can simply divide them both by 60 degrees. 60 degrees divided by 60 degrees is just 1. 180 degrees divided by 60 degrees is 3. So we have 1 times pi all over 3 radian. So the result here is we have pi all over 3 radian. All right. So what will happen here is pi all over 3 radian. That's it. Now, if you're going to multiply them, the result would be 2 pi all over 3, right? Then meters. And that's it. There we go. So here's the thing though. Why did I not include radian here? Why though? Because right, we just converted this into radian, right? Yeah, we did. But why did we not include radian as our final answer? We just only include the unit meters. Let's recall. We cancel the units. So what happens? We have only 3, right? So what will be the unit here? It's nothing. Therefore, we can just simply disregard radian, right? So we can just simply disregard radian. So what's the point then if you're going to convert 60 degrees to radian? What's the point? You know, the point is that at least you made the angle into radian, since if you're going to divide the arc length by radius, is in radians always. So make sure that the angle here should be always in radian. All right, always. Then if you're going to multiply them, you can just disregard the radians, since the radians is just a representation but unitless. All right, I hope you understand what I mean here. All right, so that's it. That's all I can say. All right, so we can now proceed to some examples. All right, so let's proceed here. Suppose the given central angle is 155 degrees and the given radius is 3 meters. What would be the arc length intercepted by the central angle? So here you can just use the formula immediately, all right? Because you know that the angle is 155 degrees and your radius is 3 meters. So therefore, we can now substitute it in this formula, all right? But if you're that type of guy who wanted to visualize it, then you can just draw. All right, draw a circle. It's okay if it's not that. How should I say this? It's not that good, or let's just say uh, a perfectly drawn circle. So just imagine. So 155 degrees, right? So assumingly that this is the central angle, which is 155 degrees, then you have two radii, which are 3 meters in length. Then your job is to find the arc length, which is this one. All right, so that's it. So again, what did I tell you? Theta should be in radians, not in degrees. Therefore, we're going to convert this angle into radians. So recall again, if you're going to convert an angle that is in degrees into radians, you're going to multiply it with pi all over 180 degrees radians. All right. So let me take a look. What is their let's just say common factor? If I couldn't find the greatest common factor, I think it's 5 actually. All right, 5. So 155 degrees and 180 degrees are both divisible by 5 degrees. 155 degrees divided by 5 degrees, you will have 31. And 180 degrees divided by 5 degrees, you will have 36. With that, we can now have our simplified expression 31 times pi all over 36 radian. And that is already the simplified expression, so we can now multiply them. We will have 31 pi all over 36 radian. So now, we can substitute. So we have S is equal to R, which is 3 meters, times theta, which is 31 pi all over 36 radians. So here I can actually simplify the side and the denominator because both of them are divisible by 3. So 3 meters divided by 3 is just 1 meter, and 36 divided by 3 is just 12. So I have wait. So I have 1 meters, 1 meter times 31 pi all over 12 radian. So the answer here would be just 31 pi all over 12 meters. Again, you can disregard the radian, all right, because it is unitless. I already explained that earlier. But then, of course, yeah, this is the exact answer, but we want to know the approximate value because overall pi is an irrational number. So let's know the approximate value, all right? Because there's no such thing as 31 pi all over 12 meters in reality because they are all approximated. So we can use our calculator. Then we can actually just round it up until it reaches the let's just say up to two decimal places. All right. So 31 pi divided by 12 is approximately 8.12. Am I right? Yeah, 8.12. So approximately 8.12 meters. So that is the arc length that is intercepted by the central angle. All right. So that's it. Let's have another example. If the radius of a circle is 10 units and the central angle is pi all over 6 radian, then what would be the arc length that is intercepted by the central angle? All right. So if you're going to draw it visually, okay, so the central angle is pi all over 6. All right, pi all over 6 radians. Then the radius of a circle is 10 units. Then the arc length, basically here, all right, this one, let me just thicken it. Okay, this one is our S. So let's write, let's basically label the given. So we have pi all over 6 radians. And we have radius is equal to 10 units. All right. So here, as you can see, the angle is in radians. So we do not need to convert it into radians since it is already in radians. So we can just simply substitute. So we have 10 as our radius. So 10 units times theta, which is pi all over 6 radians. We can simplify 10 and 6 because both of them are divisible by 2. So 10 units divided by 2 is 5, and 6 divided by 2 is 3. So we have 5 units, then pi all over 3 radians. So multiplying them together, you will have 5 pi all over 3 units. All right? But we can approximate this one. So in two decimal places, the answer would be, let me just fix my calculator for a second. Anyways, so 5 pi all over 3 is approximately 5.24 units. So 5.24 units. That's it. Now let's have one more example. So this example is just an application in reality. All right. So assume you have a car and a circular road. The automobile, basically it's a car, right? Forgive me. I use paraphrase, paraphraser tool to, just to enhance my English here. But yeah, basically this is a car. Forgive me, right? A car is located 15 kilometers from the center of a circular road. What is the total distance traveled if the car starts at the east side of the road and drives in clockwise rotation until it forms an angle of 205 degrees between its original and final position? So for you to have an idea, you draw it, all right? Like try to visualize it. So you have a circular road, right? Which is this one. Then your car is located 15 kilometers from the center of a circular road. So 15 kilometers from the center of a circular road, it implies that your radius is 15 kilometers. Alright? It implies 15 kilometers is your radius. Because remember, if you're talking about uh, distance between an endpoint and the center, that means it is a radius. Okay? So 15 kilometers from the center, that means your radius is 15 kilometers in length. Yeah. Then what's next? Then now it states here that what would be the total distance if the car starts at the east side of the road? So this is east, right? This is the east. Then you drove in clockwise orientation. So let's just say, let me use a red color. So you start from here, then you drive and drive, okay, until you form 205 degrees. All right. So that means from here to there, you form 205 degrees. All right. So once you stop at this point, you exactly form 205 degrees. All right. So what would be the total distance of this of the yeah, basically this one. Basically the arc length, in other words, all right? From here up to there, how long have you driven? All right? How far basically from here up to there? Well, first we need to convert this one into radian. So, whoa, sorry. So we have theta is equal to 205 degrees, right? So let's convert it. Remember, multiply it with pi all over 180 degrees radians. So here, I think they're both divisible by 5, I do believe. 5 degrees, right? Yeah, it is 5 degrees. So 205 degrees divided by 5 degrees, this is 41. Exactly. Am I right? Okay, good. And 180 degrees divided by 5 degrees is 36. Yeah, that's it, 36. So now we can have this simplified expression, 41 times pi all over 36 radian. So multiplying them, we will have 41 pi all over 36 radian. Now we can substitute it in this formula. S is equal to R times theta. R is your radius, so that would be 15 kilometers. Then times your arc length, your theta is 41 pi all over 36 radians. Forgive my handwriting because I have no space. All right. So here we can simplify 15 kilometers and 36 by 3 because both of them are divisible by 3. 15 kilometers divided by 3 is 5 kilometers. 36 divided by 3 is just 12. Hence, we have 5 kilometers times 41 pi all over 12 radians. Now, we can simplify them. We can now find the answer. So, 5 times 41. 5 times 41, we will have 205 pi all over 12. All right? Yeah. Okay. Kilometers. Now we can approximate this one because again, in reality, there's no such thing as this because this one should be approximated. So we're going to approximate it and let's just say up to 2 decimal places. So 205 pi, am I right? 205 pi divided by 12, you will have approximately 53.67 kilometers. 53.67 kilometers. And this is your final answer. So that means you traveled 53.67 kilometers. starting from east, going here. You traveled 53.67 kilometers. And that is all, guys. All right. I hope you have learned something in this discussion. Let's just say we can still have a practice video about this one. Maybe up to 4 questions or 3 questions, I guess. Then we can proceed now to the last subtopic of angles and angle measures. All right. So see you soon, guys.